Hello everyone, my name is Mohammad Afrid. I am doing my BTech from Andhra Institute of Engineering and Technology, which is located in Vijayawada, Andhra Pradesh. Now I am doing IoT internship project on IoT based home automation with the organization of Emertxe. Let's see the contents of the presentation. C programming and C++ programming, project requirements, embedded systems, peripherals, project integration and result. Now let's see about C and C++ programming. C is an imperative procedural language. It was designed to be compiled to provide low-level access to memory and language constructs that map efficiently to machine instructions, all with minimum runtime support. C++ is an object-oriented programming language that is viewed by many as the best language for creating large-scale applications. Now we move on to the embedded C programming. Embedded C is a set of language extensions for the C programming language. Embedded C was full of syntax and semantics of standard C. Example, main function, loops, functions, etc. Now, here we look about Arduino Uno. Arduino Uno is development microcontroller board for 8MB328P. There are 20 input-output pins present on the Arduino Uno board. These 20 pins include 6 PWM pins, 6 analog pins, and 8 digital input-output pins. The PWM pins are pulse width modulation capable pins. The crystal oscillator present in Arduino Uno comes with a frequency of 16 MHz. It also has a Arduino integrated Wi-Fi module. Such Arduino Uno board is based on the integrated Wi-Fi ESP8266 module and 8MB328P microcontroller. The input voltage of Arduino Uno board varies from 7 volts to 20 volts. Arduino Uno automatically draws power from the external power supply. It can also draw power from the USB. Here we see the Arduino Uno pinout. Here we can observe this Arduino board microcontroller at ATmega328P, and this is a USB port where we can connect the board with a computer or any device with the help of USB cable, and this is voltage regulator which is used to regulate the voltage. Here we can see the analog pins, and this is the 5 volts output, 3.3 volts output, and these are the digital pins. And this is a reset button where we can reset the program. Now let's see the project requirements for guardian light control. Input LDR sensor, output guardian light. Here LDR sensor is acting as input, so it is giving to the Arduino Uno. Arduino Uno in return gives the output to the lights. Heater and cooler system. Inputs temperature sensor LM35. Either we can use LM35 or also DH11 sensor. Output CLCD display and gauge widget. Tools we are used is Blink IoT app, Arduino Uno, CLCD and a temperature system. CLCD is an output device, that's why both the notifications and temperature will be displayed on CLCD. So Arduino Uno is giving the output to the CLCD. Temperature system, the value of the temperature is given to the Arduino, which is going to read the temperature value, and it is going to control the heater and cooler. Arduino Uno is giving the temperature reading to the Blink IoT app, where we can see the temperature value from the app also, even though notifications also. In return, it is going to control the heater and output wall. Similarly, we can see the water tank control. Inputs are serial tank, output CLCD display and water gauge widget. Same tools we have used here, Blink IoT app, Arduino Uno, CLCD, but in place of temperature system, here we are using water tank. In the previous project, we have given the temperature value, but here we are giving the volume of the water to the Arduino Uno. In return, we are getting inlet valve and output valve controls. On the LCD, we are going to display notifications and volume of the water. Similarly, Arduino Uno is giving the volume of water value to the Blink IoT app, where we can see the output, similar notifications, and it is going to control the inlet valve and output valve. And these are the peripherals: IC, PCF8574 and 12C LCD. Here you can observe the readings like notifications and temperature values. These are the peripherals: LED, ETHW5500 and LDR. This is LDR. Peripherals: temperature system and serial tank. This is a tank where we can increase the level of the water. Tools or software used: Arduino IDE, Null Emulator, PixSimLab, Blink IoT application, Virtual Serial Port Emulator. And this is the project integration. Here we can see that this is serial tank where whenever we increase the volume of water, specific task is performed here and LED will be glowed whenever the temperature value is raised by above 35 degrees. And this is a project integration. These are some of the screenshots of the output which we have done. Here I have arranged my all the components together. Now you can see that whenever I am increasing the intensity of LED, the LED is going on, and whenever I am decreasing the intensity of LED, it is going to off. This is one type of home automation project where we can manage it, where we can control the LED. And now we move on to the heater and cooler, where this is also one of the project which we have done. Now I am going to turn on the heater, and we can see the temperature value is increasing 29, 30, 31. According to my program, I have given the temperature value of 35 where the heater pin is turned off. Now I am turning on the cooler pin. Now we can see that the value of temperature will comes down slowly. Here this is the main operation where we can control the cooler pin and heater pin with the help of Blink IoT app, which is our major project we have done in this with the help of using IoT. Now let's move on to the another one. Now here I have taken serial remote tank where this is where we assume this is one small tank where we have inlet valve and output and outlet valve. The main is whenever we turn on the output valve, the water starts flowing down, and I will set specific range. From then onwards, automatically inlet valve will turn on and the water will start filling. Now let's see practically the outlet value valve is on. Now we can see that water is coming down and down. Now I have set up some particular limit like 2000. Whenever it reaches the level of 2000, it starts inlet valve turns on and the water starts filling. Here we can now with the help of this project, this project is done by my group and this PPT is submitted by myself. Mohammad Afrid, MD.AFRAD 2003 @gmail.com. Thank you, Emertxe, for giving me this golden opportunity. Thank you.